Well, hello everyone, and welcome to the Australian Academy of Technological Sciences and Engineering webinar on climate smart farming for future food security. And a very warm welcome to all registered participants from both Australia and overseas. My name is Sue McCluskey and I am the moderator for today's event. I would like to begin by recognising the lands upon which we variously meet, I being on Ngunnawal country, and acknowledge elders past, present and emerging. I'm really honoured to be asked to moderate this webinar today, where we will hear from two distinguished speakers about the lessons from India and Australia on international linkages. I am the special representative for Australian agriculture, and in this role I engage closely with key international leaders on trade and market access, agri-food systems, sustainability and climate smart agriculture. And my main message is that while agriculture may be seen by many as the problem, it can and must be part of the solution. I'm also a commissioner for international agricultural research and know how important it is for developed countries to provide research and development support to developing countries to help them meet the climate challenges that are having a devastating effect on their food security and food safety and their access to healthy and nutritious diets. I note that both our speakers today have had close links with ACR, Dr. Perota as a previous Policy Advisory Council member, and Dr. Austin, of course, as previous CEO. We have many science and technology innovations, both in Australia and overseas, that can help us to meet the climate challenge. But we must work together, share our research and knowledge, and collaborate to truly harness the power of the collective effort. No one of us can do this on our own. So let's hear from our two speakers. I'm not going to provide full details of their biographies as you already have them, but suffice to say that we have two eminent experts in this field. Firstly, we will hear from Dr. Raj Perota, who through a number of senior roles has modernised the Indian National Agricultural Research System and created more than 30 new institutions. He is also a Foreign Fellow of ATSE. Our second speaker is Dr. Nick Austin, who is recognised internationally and domestically for delivering innovative solutions to complex technological and political challenges, working to improve the lives of smallholder farming families. Today, Dr. Perota and Dr. Austin will discuss climate smart agriculture, the opportunities to enhance science linkages between Australia and India, and what mechanisms we can use to strengthen collaboration in these areas. So thank you, and over to you, Dr. Perota.
Thank you. Let me share my PowerPoint presentation. It's a privilege for me to participate in Agriculture and Food Forum being organized by ASTE. Today's subject for discussion is climate smart farming for future food security. We are all aware that there are global challenges as far as food security challenges are concerned. Globally, we would be 9.8 billion by 2050, needing about 56% more food. And to do so, possibly there may not be additional land that is required, so we'll have to go vertical for improving productivity through agricultural efficiency. Also, maybe that we have to look for out-of-box options such as cut on food waste, rethink on consumption of meat, improve production efficiency, and go in for regenerative agriculture. Challenges for India, which has now become most populous country in the world, overtaking China, are again daunting in the context of producing every year more than 6 million tons of food grain for the population that we add to our numbers. There are issues related to sustainable development goals, which are important and have to be achieved by 2030, no poverty, zero hunger, and also climate action are the important aspects relating to agriculture in this respect. And when we look at climate action, agriculture contributes about 33% of greenhouse gas emissions. be those through land degradation, burning of biomass, or through agricultural practices such as raising of livestock, inefficient use of fertilizer, rice cultivation, and above all, around 6% is contributed by the post-harvest uh, losses which are occurring globally. Uh, the message that we got recently from COP27 is that time is running out. Uh, Last 7 years have seen the most hottest years, and we are at a tipping point now in the context of meeting our food demands in future. Looking at the national level in India, we are already realizing losses occurring to the extent of 5 to 20% in different crops, depending on the pattern of monsoon and the climate variations. COVID-19 pandemic has also drawn attention towards uh, good food, nutrition for health, and not only nutrition for health, but also for immunity. And it seems we have added almost 157 million more people above those of 800 million below poverty line in 93 countries, and food crisis is already being faced there. UN Food System Summit held in 2021 had emphasized that for future food security, we shall have to again go back to local food systems and conserve our natural resources more effectively. So globally, we are in the midst of a storm, and we have to look for way forward by which we can address these concerns. And for climate change and climate smart agriculture, what we now have to look at is that we think globally as to what is happening and then act locally. And in that respect, Green Revolution, which happened in India, was a science-led revolution around the dwarf wheats and photoinsensitive wheats and rices. And that's how we could have better responses to higher inputs. But over the years, we have seen that there are second generation problems around natural resource degradation. So we have to have a paradigm shift from unipillar approach of genetic resource management to that of natural resource management, and that also through sustainable intensification and diversification of agriculture. So the strategy for climate smart agriculture would demand quality science, a strategic partnership like what we had for Green Revolution between India and international centers like CIMMYT and ERI. Uh, we are talking here of partnership between Australia and India, and we would require more investment. Also, it is now not the issue of production, but post-production. So value chain and the concerns relating to farm to fork, uh, particularly in the context of globalization of agriculture and marketing. And we would require more efficient methods of transfer of technology for scaling innovations. We also require for climate change variations and to reduce the greenhouse gas emissions, a twin pillar strategy around adaptation and mitigation. Adaptation in the context of time of planting, changing varieties, new cropping systems, new areas for shifting the crops, etc., etc., and also mitigation, which would definitely require more support and commitment at the national level by policymakers for reducing the net emission of greenhouse gases. We have had good successes through adaptation, through the breeding approaches, by going in for extra and early extra varieties of various crops. Here is the case of chickpea, which was earlier a crop of the North India, but now with early varieties, one can grow crop all the year round, and also at the entire national level from south to the north. The adaptation is already now being recognized, and in Japan, the apple farmers are moving up at higher elevation because the areas of apple production seem to be having now high increase in high temperature, etc. We have also to have a strategy while we look at our agriculture to see as to how can we reduce greenhouse gas emission, and the crops that are emanating more of this are rice, wheat, potato, cotton, mustard, etc., which require more of water compared to others which are relatively more climate smart crops in general. So climate smart agriculture would also require dependence on agrobiodiversity. Fortunately, we have an asset, but this agrobiodiversity has to be explored, not much researched, and has to be conserved. And in fact, many of them are facing extinction, and therefore time is running out. We have to see that these are not only uh, collected and conserved, but also evaluated and genetically improved. You have materials like this, which are becoming extinct, but they are the best for sand dune stabilization, like this particular creeper, Citrullus colocynthis. We have grasses which grow in the regions which are mainly arid, with rainfall to the level of about 100 to 200 millimeter, and grow in only sandy soils, but very nutritious. So these materials need to be also researched and genetically improved. There are shrubs, the kind of variability just for one shrub you see here. So what is required is to lay greater emphasis now for research on such materials for meeting our future food demands. Even the trees, and trees are unique. Prosopis for multi-purpose, Salvadora for salt tolerance. And when we look at Australia, eucalyptus, which has come from Australia to India, is also very hardy and salt tolerant species. Atriplex, which is a shrub grown extensively in the Western Australia for the sheep raising, and we have tolerant grasses and shrubs like salsola, which are highly salt tolerant. There are also the animal breeds, whether those cattle or buffalo, which are highly tolerant to high temperature and um, harsh climatic conditions, providing enough of income to the farmers with less of food and feed requirements. But to take care of such kind of genetic variability, we shall need institutions like the Genetic Resource Institute for plants, animals, fish, insects, and microorganisms, and enough of variability exists there, but we would require then harnessing of science for new gains, for which we can think of genetically modified crops, CRISPR-Cas technology, bioinformatics, robotics, artificial intelligence, farm mechanization, and also to improve soil health and environment for sustainability. This all will require public-private partnership and protection of intellectual property rights. Otherwise, this would not happen. I come to my last two parts. One is the commitment for Paris Agreement, which has to be met by each nation by 2030. And every country is required to meet 2020 targets. Fortunately, India has fixed higher targets, almost double, 35 for the reduction in emission intensity. We are on track, and clean energy by non-fossil fuel sources. Uh, India is now one of the largest uh, uh, the source of energy by going in for solar uh, energy system. Additional carbon sink is our problem. This possibly would not happen unless we shift from the forest strategy, where there is no land to increase forest from 25 to 33%. So we will have to think of agricultural practices like scaling agriculture, promoting agroforestry, efficient use of fertilizers, managing the bovines for reducing greenhouse gas emissions, and good agronomic practices for cultivation of crops like rice, wheat, etc. Globally, we have seen conservation agriculture has great potential, as it already has covered 200 million hectare area. Australia is uh, advancing very fast in this over the last 1 decade, but in India, in drylands, this has not yet picked up, where there is great opportunity. The past collaboration between ACIR and that of research institutions in India to come up with machinery, which is very important for scaling conservation agriculture. This happy seeder would have not been possible if that kind of collaboration and support was not possible. So we require such machines to be also used. We require other advanced technologies like water harvesting, solar energy by solar panels, and then also to go in for drip system of irrigation, and go in for fertigation and conservation agriculture. But it all will require enabling policy environment, and that enabling policy environment is a challenge. We have had a lot of dialogues with policymakers in partnership with OSAID and ACIR through the program that is there on conservation agriculture for sustainable intensification in Nepal, Bangladesh, and India, with which John Dixon had been quite actively involved. Uh, for going in for conservation agriculture, we shall require also the strategy of supporting farmers for environmental services. And I think now there is a good awareness. And finally, we need to build partnership of the kind that had in the past helped for green, white, and blue revolutions. Uh, we are talking now partnership between Australia and India, where there is a lot of common ground and similar problems, and we can learn from each other as a win-win approach. Interinstitutional collaboration, MOU between academies, human resource development, increased funding support, all are important, and for which we have institutions on both sides to link more effectively. There had been impressive collaboration in the past, uh, right from 1960 onward. And Sir John Crawford, through ACIR, CEOs, we have had a lot of support. Nick is going to talk after me. And John, I have already mentioned, CGIR, Director Generals, Jim Ryan of ICRISAT, Tim Reeves of CEMET, Merrill William of Fish Center, and Peter Carberry again of ICRISAT. And there are scientists like Derek Bailey and John Dixon. And the partnership with Sydney had been very significant for rust management in India. And McIntosh had trained the world's best wheat breeders, Rajaram and Ravi Singh, and also trained many scientists from India. And he is still supporting the uh, Bill and Melinda Gates initiative of Global Rust Initiative. Uh, we therefore see that there are options. Finally, I would like to say agriculture be not seen as a problem, but rather a solution for future food, nutrition, and environmental security. Climate smart agriculture offers the best options. Increased R&D support would be needed to scale innovations relating to these approaches, and a strong partnership is also necessary for mutual benefit, and time is ripe for action on both sides. And since it is the Millet International Year, I would like to say that I draw your attention again that we have to go back to local food systems and improve them and use them both for good health and nutrition security. Thank you very much for this opportunity. I go back to Sue, please.
Thank you, Dr. Peroda. We'll pass straight over to Dr. Austin for his presentation. Thank you, Dr. Austin.
Thank you very much, and let me share my screen. Wonderful, thank you. It's a pleasure to present today, and it's an honour to be sharing the session with Dr. Peroda, someone who's had a lifetime contribution to agriculture in India and globally. And Raj, I fully concur with your 5 conclusions, and I arrive at a very similar position. I'd also like to recognise the role that John Dixon's played in bringing the event together with the support of the team at ATSE. Like Sue, I'm joining from the lands of the Ngunnawal and Ngambri people, and I too pay my respects to elders past and present and the traditional owners of the lands on which each of you are joining. The title of the webinar, of course, is Climate Smart Farming for Future Food Security. I'd like to reframe it slightly with a proactive orientation, talk around transforming food and agriculture to be climate positive. I'd also like to widen the frame a little bit and consider not just farming, but the food system, because farmers, of course, respond to what consumers demand. So I'll draw on examples from around the world, as well as exploring linkages between Australia and India. We're at a make or break moment for the planet. We've got to produce more nutritious and healthy food, at the same time reversing the environmental degradation and malnutrition and poverty that characterise our present systems. So food and ag is in the spotlight around the world. PepsiCo and General Mills, among other global food giants, recently announced goals to transition supply chains to regenerative agriculture. We see top chefs around the world opening vegan restaurants. China's made food waste reduction a priority. The US is developing a strategy on climate smart agriculture. The European Commission recently announced a sustainable food strategy called From Farm to Fork. And all the attention is warranted. The $18 trillion global food system is a problem for our climate. It's also a problem for our health and a problem for our environment. And so there are a few issues with such widespread benefits, and there are probably a few more pressing needs to accelerate the transformation of food system around the globe. So changing what we eat, improving how we farm, concentrating where we farm and wasting less can help address the climate crisis, but can also lead to improvements in health and protecting biodiversity and enhancing the lives and livelihoods of people around the world. So I'll talk about each of those 4 actions briefly, but first I'll recap how our food system is driving climate change, and Dr. Peroda's touched on this as well. Food systems being responsible for 18 gigatons of CO2 equivalent, or roughly a third of global anthropogenic greenhouse gas emissions. As we increase food consumption for the world's undernourished, and as the population grows, agriculture's climate impacts will become an even greater concern. But even as rates of growth slow, the global population is expected to reach around 10 billion people by 2050, and that'll result in an increased food demand of estimated to be around 55% if current consumption habits continue. Agriculture is already using half of the world's vegetated land, and increasing food production by clearing forests or or other ecosystems for cultivation isn't an option. We need intact ecosystems to support life, absorb carbon, of course. So food systems contribute to climate change in 4 main ways, shown on the right in the pie chart. So livestock, particularly ruminants, emit methane, potential greenhouse gas through digestion and manure. Cultivation of rice also emits methane. Synthetic fertilizers are produced from fossil fuels, and when they're applied to crops, they can combine with microbes in the soil to emit nitrous oxide, another potent greenhouse gas. Clearing of vegetation and conservation of forests and other natural lands for livestock and crop production release greenhouse gases. And once those lands are cleared, their ability to absorb carbon dioxide is reduced. And despite the fact that millions of people around the world still don't have enough to eat, roughly 1/3 of the world's food is wasted or lost. Food waste ending up in a landfill produces methane as it rots. In addition to wasting the food, it also wastes all that went into producing it. And finally, the supply chains, or the processes used to transport, process, package, sell, redistribute food, they all generate emissions from tractors, trucks, chemicals used to cool food, and so on. Importantly, the relative contributions vary with income level. So of that 18 gigatons of CO2 equivalent that the food system releases, roughly 5 gigatons comes from industrialized countries and mostly from energy waste and industry. And the balance, the 13 gigatons, comes from developing countries, mostly from land use change and production. So transforming agriculture and foods got multiple benefits. It not only helps tackle climate change, it simultaneously improves the outcomes in other areas such as health and equity and biodiversity, fresh water and resilience. There are strong health linkages. On the demand side, healthier diets create climate friendlier diets, and on the supply side, improved agricultural practices also reduce antibiotic resistance, exposure to pesticides, zoonoses, with associated health benefits. Agriculture can be a powerful driver of equity and a path out of poverty. In developing countries, the ag sector is between 2 and 4 times more effective in raising incomes among the poorest communities compared to investments in other sectors. And in developed countries, substandard working conditions and low wages that characterize the food industry jobs contribute to health and the economic disparities. Inequality can be reduced by improving agricultural efficiency and productivity, providing access to markets, improving working conditions, increasing incomes and human welfare. Food's the largest cause of biodiversity lost by driving conversion of forest and grasslands into crop and rangelands, and by avoiding further land conversion and improving productivity of existing agricultural lands or sustainable intensification, we can protect forests and slow biodiversity loss. 70% of freshwater use is for agriculture, and agriculture in turn has practices that pollute groundwater and contribute to aquatic dead zones. Improving agricultural systems can have benefits both the quantity and quality of water available for people and for wildlife. Much of what we need to do to reduce emissions from ag will also make food systems more resilient to extreme weather events and to other shocks expected to be more frequent with a changing climate. So food and ag is a pretty unique space for action. It's got the potential to inspire and engage diverse complements of stakeholders, including citizens and governments and businesses and not-for-profit organisations. There are many possible pathways to achieve climate smart food systems, whether it's through transforming fundamental systems via policy and corporate practices or changing individual behaviour. I'll very briefly unpack 4 of those. The first, changing what we eat, and I've already touched on this. Meat and dairy responsible for more than half of the agricultural emissions. Demand for meat's growing rapidly and projected to double by 2050. And the primary geographies responsible for meat consumption are the Western and wealthier countries where people already eat more meat than's healthy. In China, Southeast Asia and other rapidly growing economies, meat consumption is increasing with income growth, urbanisation, and as Western diets become more common. Healthier diets, those that are full of vegetables and plant-based proteins, can reduce our climate impact, along with the risk of death and mortality, cardiovascular diseases and stroke and diabetes. But diets are deeply cultural and they vary by geography, so efforts to change them really need to be attentive to that context and tailored accordingly. Furthermore, as Western diets and their associated overconsumption of meat become more common, 770 million people still go hungry globally. So for some, especially in developing countries, consuming more calories, including meat, is necessary for health reasons. And livestock production is an important economic driver in low-income contexts. Improving how we farm, in addition to shifting what food we consume, we need to improve how we farm to meet the world's climate goals. Many current practices contribute to climate change with projected increasing emissions. We can reduce emissions from ag with a number of practices. We need to radically reduce the amount of livestock consumed and better manage what remains. Rather than concentrating livestock in feedlots, it need to be integrated in crop production systems through rotational and controlled grazing. We need better use of fertilizer and manure. The rich world can reduce synthetic fertilizer use while maintaining crop yields and better integrate livestock into farming. We need to improve yields and change how we grow crops using different varieties, diversifying what's planted, reducing when and how often land is ploughed, planting cover crops, things like clover and rye that restore nutrients, and incorporate trees that can increase crop yields and reduce emissions. We also need to better manage rice fields. Cultivating rice without releasing as much methane is possible. An important shift needs to be accelerated in China, India, and Southeast Asia. Not only must we stop the growth in emissions, we must turn agriculture from a source of emissions into a sink, that is a way to store carbon, and modelling's shown quite comprehensively that implementing the sort of changes I've just described can reduce emissions from ag even as population growth. Estimates of the potential to reduce greenhouse gases by changing farming practices range from 4 to 38 gigatons of carbon dioxide equivalent per year. Healthy soils contain more carbon, and many of the practices that increase soil carbon and prevent it being released into the atmosphere also benefit productivity. So the scientific community is still researching how long and how much carbon can be sequestered in this way. Some of the estimates are showing very large potential. And the shift in practice should be led by the regions with the largest means and which have contributed the most to emissions historically, the US, Europe, Canada. Consumption in industrialized countries drives production in other regions, of course, which also have large potential for reducing greenhouse gases, China and India and Africa and Latin America. Agriculture already uses almost half of the world's vegetated land. Increasing production by simply using more land and clearing forests will harm natural ecosystems and further drive climate change. And natural ecosystems, of course, are critical for storing greenhouse gases and providing fresh water, protecting wildlife, biodiversity, and so much more. So in addition to making agriculture more productive and more efficient, additional efforts are required to avoid further land conservation and protect forests, restore oceans and fish stocks and other ecosystems and halt biodiversity loss. Such work will not only ensure that forests and other ecosystems continue to provide the essential goods and services we need, but also preserve habitats for threatened and endangered species and secure the rights and livelihoods of Indigenous and forest communities. Estimates for the potential to reduce greenhouse gas emissions range from 1.5 to 13.7 gigatons of carbon dioxide equivalent each year. Protecting high-value ecosystems and integrating conservation into forest and agricultural land used for production and securing tenure for Indigenous peoples and smallholder landowners are all important, and we know that they can work. So for example, between 2005 and 2012, Brazil sharply reduced deforestation even while substantially increasing soy and beef production, demonstrating the potential to intensify productivity and thus expand agricultural production while still protecting forests. We waste a tremendous amount of food, around 30% between the field and the table. Food loss and waste not only squanders the water and the energy and the land and other resources that went into growing and distributing, but a large proportion ends up in landfills, as I've touched on. In fact, wasting food contributes 8% of our global emissions annually when accounting for production and land use change and supply chain emissions. So food loss is primarily a concern in developing countries where hunger remains an even larger problem than developed. And common causes of food loss in developing countries are a lack of access to infrastructure like buildings to store food or roads to transport it or power for things like refrigeration that are needed to cool it. In developed countries, of course, poor prediction of consumer demand and high consumer standards for how food looks are common causes of food wastage. The most recent food waste index report from the UN Environment Programme found that household food waste generation is broadly similar across high and upper middle and lower middle income countries. It happens for a range of reasons, from poor predictions of what will be consumed in a restaurant or household to a lack of awareness of the problem. So, apologies. So reducing food loss and waste can save between 5.3 and 9 gigatons of CO2 equivalent a year. If some of the recovered food goes to people who are hungry or undernourished, currently more than 820 million people, largely in sub-Saharan Africa and South Asia, then reducing food loss and waste is one component of feeding a growing population without increasing production or converting more land to agriculture. So, for example, reducing food loss and waste by 50% by 2050 would close the gap between food available and the food needed by 2050 by more than 20%. It would avoid the need to convert an area of natural ecosystems roughly the size of Argentina into agricultural land. So finally, let me connect this back to the India-Australia collaboration. And the 4 areas I've discussed, changing what we eat, improving how we farm, concentrating where we farm, and wasting less food, are some of the most promising avenues for achieving climate-smart farming for food security. But it's not going to happen spontaneously. It requires innovation and support for science and research. Recently, the Commission on Sustainable Agricultural Intensification, or COSI, concluded they concluded in their report that a major boost in global support to innovation in agricultural systems is urgently needed. An additional $4 billion for research to reduce hunger, additional $6.5 billion for action on climate change, and $4.7 billion for research addressing water and nutrients. India alone spends over $3 billion US annually on agricultural innovation. India has 70% of the global population, but only 4% of the world's freshwater resources. So both India and Australia are going to be adversely impacted by a changing climate. We've got a long history of collaboration, as Dr. Prode has touched on, across research, education, development, capacity building, which underpins strengthening ties. And I'll cite just 3 examples. ACR has been mentioned already, the Australian Centre for International Agricultural Research, which has supported research for development partnerships on shared priorities. The Australia-India Strategic Research Fund is Australia's largest fund dedicated bilateral research, supports collaborations between scientists in India and Australia on including agriculture as a priority area of research. And more recently, the Australian Researcher Cooperation Hub India has been established to support engagement between India and Australia. Its primary aim is to strengthen and increase bilateral research collaboration and showcase research excellence both in India and in Australia, again with agriculture, environment, climate change and water as research areas of focus. So the potential to deepen and advance collaboration on agricultural and related sciences is tremendous, not just in the public sector, which has characterized the relationships to date, but across the agribusiness sector more broadly. India is a technology powerhouse. Agriculture is increasingly tech-enabled, and there's untapped opportunity for joint innovation and commercialization of emerging tools, including around big data, satellite, bio-based technologies, artificial intelligence, and climate-smart agriculture. One avenue might be to informal ATSE dialogues between India and Australia on transformative agricultural systems, but perhaps that's something we could explore in question time. Sue, I'll hand back to you. Thank you.
Thank you very much, Dr. Austin. What a terrific webinar we've had, listening to 2 absolutely fantastic speakers on really the opportunities for climate smart agriculture, how agriculture really can be part of that solution, and also opportunities for collaboration. Can I encourage you to think about questions you would like to ask our speakers and put them in the Q&A section? We have a couple of questions there, but I might start off with a question for both our speakers. And it really picks up on something you both spoke about around collaboration. And that is, what could be the drivers for effective international linkages between India and Australia? Drawing on your knowledge of working in this area, what's worked in the past that has really been very impressive in terms of collaboration? And what do we need to translate that to the future so that we can really start to really uplift the collaboration we have between both countries? Who would like to respond first?
Oh, well, I can probably briefly mention that there is great strength both now in Australia and India for collaborative research, particularly in the area of climate smart agriculture. As was mentioned, livestock contributes considerably for greenhouse emission, and managing livestock and also post-harvest losses are the areas which need to be looked at. Similarly, conservation agriculture need to be scaled in drylands, where Australia has good now achievements. And no doubt we have been earlier working on crops like wheat and also legumes in partnership with these universities, CSIRO. But what is now required is to make use of new science for searching new genes which are tolerant to stresses related to drought, salinity, heat, etc. And these are common problems. And I do see that there is a lot of work going on in partnership. But if I recollect, when I was serving on ACIR Research Advisory Committee, the collaboration had really gone up much faster to a level of more than $2 billion at that time. Oh, sorry, $2 million at that time. But I understand that now this has declined. So probably there is need to have, as Dr. Austin mentioned, a dialogue or roundtable discussion in terms of identifying common areas for partnership. And human resource development is very, very important. I'm not talking of just only the graduation and postgraduate level, but developing the capability of scientists working in a specific research area. And ACIR is known for that compared to other organizations for working together in partnership between scientists on both sides and coming out with best possible publications.
So if I might follow on and endorse everything Dr. Paredes has just said, and I think to pick up on some of the emphasis that he's made on common problems and to build out some of the also common opportunities between our countries and the benefit that that might bring globally. So our countries are increasingly important partners in promoting regional security and stability. Two-way trade in goods and services is growing. Agriculture and agribusiness trade has been gradually strengthening. It's got the potential to become a key promoter rather than a constraint on a deeper relationship between our countries, and particularly if the socioeconomic and cultural aspects are explicitly accommodated. So just in last December, the interim Australia-India Economic Cooperation and Trade Agreement, or the AIACTA, it entered into force, and it establishes some new and commercially significant market access opportunities for a range of Australian agricultural commodity exporters. So both countries are looking to secure greater agricultural outcomes through more comprehensive agreement this year, which speaks to some potential collaborations and partnerships in technology and innovation, more in the agribusiness space. Both countries have close cooperation in multilateral fora, like the G20 and the UNFAO. There's tremendous potential to build not only on those, but to explore where working together for benefit of other nations in the region may exist. So trilateral partnerships between India and Australia. And I know that they were some of the areas that ATSE had piloted, and I think there's enormous untapped potential to build out those sort of collaborations.
Thank you. Thank you. Look, I'm going to go to some questions because we're getting them come in fast and furious now in the Q&A section. Dr. Perrotta, we've got a couple of questions in relation to drylands. So I'll bring them together. So there's a question around partnerships for transforming agri-food systems where the drylands is unexplored, and how can we strengthen partnerships? On the other hand, we've also got a question around dryland agriculture being a success story in Australia. So how can the collaboration between Australia and India benefit rain-fed agriculture in India? So I'll pass to you for response there. Thank you.
Well, I think I see great potential of partnership for dryland agriculture research. Firstly, by identifying the institutions on both sides, and partnership has to be around scientists, not only the institutions, and their commitment. And for that, the kind of collaboration which had been in the past is likely to be very helpful. Even the Dryland Institute in India was established at the advice of Dr. Christian, which I had mentioned in the beginning of collaboration. And the blueprint for that institute was given by him as expert to the government. And the kind of support which we have been getting lately through the ACIR or regional program on conservation agriculture for sustainable intensification. There are very good, achievements in terms of what can be done to scale the innovations and where are the gaps. But now is the time to see that we catalyze the policymakers on both sides. And especially, I would say in India, that we are struggling to do so. And secondly, to take technology to the farmers' fields. And I see that conservation agriculture is one important area which will help in greening the gray areas, which we call drylands, which were bypassed by green revolution in the past. But now is the time. You just cannot ignore them. And especially you have to go for local food system, then they are grown in these drylands. So for our future food security, for diversification, and fortunately both India and Australia have rich agro-biodiversity, which need to be studied, improved, and even exchanged. And that exchange part would come only through mutual trust and collaboration.
Thank you, Dr. Perrotta. And look, I'm going to stay on the theme of collaboration here between Australia and India. And we have a question that actually refers to the recent IPCC synthesis report that highlights there's a need to increase investment in agriculture, forestry and land use. Do you think that a partnership between India and Australia will provide an opportunity to raise the level of investment to meet the ambitions of the Paris Agreement?
Yeah, I suppose this question is to me. So sure, why not? This now I see that the environment is much favorable for partnership between Australia and India at the highest level. Policy support is very critical. The cradles of success of any revolution that we had was the policy support. So if both sides are willing to give priority, and in both countries the economy is largely dependent on agriculture. So I suppose that can be one area identified, and government on both sides, foreign ministries on both sides, and the institutions like AST and also National Academy in India and CSIRO, ACIR need to also see where one can get more benefit through collaborative research. Because it is not only funding, it is also the outcome. And outcome has to come in terms of Borlaug's, ideology that revolutions would just not come by having institutions, but you need the human resource. And you need to work together and have commitment. And what Nick said, that area also is very important, is the post-harvest management, value addition and marketing, in which Australia has great strength. Luckily, India has internal market for consumption. But if Australia has to consume internally, possibly there would not be much sustainability of agriculture there. So the export potential, especially of livestock export, you have moved from meat export to live animal export, the quarantine system between the two countries, which is very important in terms of globalization, and value addition are the areas where I think what we need is to understand what do we want, where there is strength and where there is need on both sides, and then move together. And that's where academies have very important role to play. I deal with one think tank in India just for policy advocacy. And it is not easy to convince policymakers, but they want informed knowledge and better communication, which is science-based.
Yes, Nick, you can add to that.
I was going to follow on, if I might, on and again in full agreement with Dr. Pereira's points. The aspect I wanted to build out a little more was the and Raj, you made this point. It's not just the quantum of funding, and the way in which that funding is directed is a really important dimension. I mentioned the COSI report and making the case for significantly increasing funding, and I don't think that should be too much dispute of the fact that greater investment is needed. But the transformation of agricultural systems to be climate smart can't come at the expense of food security or undermine the incomes, particularly of those producers in low-income contexts, smallholder farmers. And so finding that path forward, and I touched on 4 sort of themes or elements that help address those objectives concurrently, and that it's not a zero-sum game for the climate, for incomes and for livelihoods. Interestingly, in the global south, there's around $60 billion invested in agricultural innovation systems. A small proportion of that is directed towards funding that can be classified as having detectable in environmental aims, and so that's about 7%, about 5% with both social and environmental aims. So it speaks to opportunities for different forms of funding, increasing the total quantum, and so not looking just at a public or philanthropic capital, but the way in which private investment can be catalysed, and the role that agribusiness can play in driving the sort of innovation that delivers the productivity that is needed for global food security, but at the same time addressing the challenging climate goals.
Thank you, both Dr. Parada and Dr. Austin, for that. Now, Dr. Austin, I'm going to stick with you for the moment. I've got a question around livestock systems, and then I'm going to add my own question to it. So you talked about the need for livestock production to be better integrated into cropping systems and move away from feedlot approaches. But isn't beef production actually moving more towards feedlots? Wouldn't it be important to consider reducing extensive rangeland grazing? And I will add a question to that, which you would expect from a cattle farmer. You talked in your presentation about changing what we eat and to consume less meat. So two parts. One is, what does that mean for circular food systems when we think about production and consumption and waste if you take out meat? And what does this also mean for our least developed nations who struggle to find any protein source, let alone consider what plant-based proteins versus meat may mean for them?
Great question, Sue, and I perhaps should have anticipated those from you, knowing where your interests lie. And I think it's a really helpful question in that it opens up that reality that there's not one solution for all. And I hope I've made the point clearly enough as I presented that the formulas and the sort of approaches for the rich world, for countries with high incomes and with the so-called Western diets are going to be very different and look very different to those in Sub-Saharan Africa or South Asia, where per capita intake of animal source protein is below what's desirable from a nutritional health perspective, and livestock plays an important role in livelihoods and incomes. So it's a case, and it's a really good example of where using one approach and anticipating that applies elsewhere is highly problematic. So the other thing that I think it highlights is the criticality of good numbers, and underpins the importance of science and research, so that we're discussing things on the basis of evidence and science, and we can, to the extent possible, move away from the more emotive elements. And so I think there's even implicit in your question some elements of the need to unpack what the contributions of intensive livestock sector, feedlotting versus rangelands, and perhaps that's a longer conversation that time will permit in the few minutes we have left. But I think it just really underscores the value of investments in rigor in understanding and quantifying those contributions. At the same time, a lot of what we're talking about is values-based. And if we simply rely on numbers to chart a path forward, we'll come up with solutions that are perfect in concept, but just don't work in reality, because we're talking about things that are deeply held culturally or socially or societally around objectives and priorities. And so needing to bring that understanding to the set of prescriptions is equally important.
Thank you for that response. Now, we do have quite a number of questions, but we are fast running out of time, but we will endeavour to respond to those questions out of session. I think the real key that we've heard today was not just that there are immense challenges facing us in terms of food security within agri-food systems and with climate, as well as other global challenges that are coming our way. The real key, though, is there's much we can do to collaborate, to work together, to be able to find solutions, and to be able to translate the global solutions that we come up with to what it means on the ground, locally led, place-based solutions that really are fit for purpose. Thank you everyone for participating in today's webinar. I'd really like to give special thanks to Dr. Raj Perota and Dr. Nick Austin for their terrific presentations, which will be available for you. As I said, we will look to respond to the questions we didn't get to respond to today, but thank you everyone for your time, and I wish you well in the rest of your day. Thank you.
Thank you. Bye.